Good morning, one and all. Am I audible to you?
Yes, ma'am.
Yes, ma'am.
Yeah. So, welcome back to the second session. And now I'm going to take a session on Python tutorial. In this session, I'm going to provide the basics of Python as well as how Python is useful for the machine learning. So, these topics I will cover in this session. So, now the content which I'm going to deliver today is first of all, I'll give introduction about the Python and what are the different features and how it is different from the other languages. And I'll give a brief about what are the Python basics. And later I will try to provide the hands-on on Python libraries. Next, I will introduce sklearn for machine learning. And I also show you how to see the data by taking some sample data set, and later on how to apply the different supervised and unsupervised learning, and how to evaluate those approaches using the Python. This is the today entire session content. Now I'll go with the introduction. If I'm not audible or any disturbance, please let me know so that I could correct from my end. So the basically Python is an open source and high level language, and generally used for the general purpose programming. So this was actually created in 1980s and released in 1991. So this Python works in a different platforms like Windows, Mac, like Linux, Raspberry Pi, etc. And the thing is, it provides the massive amount of libraries which is helpful for doing the programming or problem solving in different areas like as string processing, mathematical computation, or working with the internet protocols and software development as well as the engineering. And also operating system calls like how we do for the C language. Similarly, here also we can do with the operating system functionalities by using the operating system interfaces. It's not this limited. You can also use it for the different AI and ML and data analytics and other different images, audio, video processing. So now, what are the basic features of the Python? I would like to give. The main are the key features of the Python is first one is it is very simple. So what is actually meant by the simplicity in this Python is it allows the developers to write code very quickly and clearly. What is meant by providing the code quickly and clearly is it means that no need to write a complete code. Like suppose if I want to write a line of code, then I have to use some of the syntaxes, they're very lengthy, and we have to use some semicolons or brackets and all. So instead of that, you can write it in very simple way, and that makes to reduce the code size in a few lines. And you can write it very natural language type of coding so that we can clearly understand what that code actually trying to do. So this is actually comes under simplicity. Now the next one is readable syntax. As I mentioned now, it is almost the simple lines are look like an English language keywords only. For example, if you take the printf statement. So in the printf statement, if you see in the C language, we will write the printf and open bracket and colons opened and quotations we will give and the different percentile symbols to specify the data. So these are the syntaxes we will trying to use in a C language, but instead of that, if you take in a Python, you simply print and you open the bracket and simply mention it is a variable or a text simply by taking it in the type of the data. So this is how much simple it is, and it's like a natural language keywords. And indentation also. Now earlier what happens in the C, if you consider the C language, we have to just to use the brackets for scope of that program, but here we nicely provide the indentation so that we can understand the scope of the code at a particular line. So this makes a very readable program, I mean readable syntax. So next one is easy to learn. Obviously the first two features which I am talking obviously make you to learn the programming language easy. So with the help of these two features, we can say that Python is very easy to learn and easy to code your program. So next one is dynamic typing. So the dynamic typing means here, suppose if I want to give an integer type of values, and generally in a C language, what we do, suppose int space variable name semicolon. So, and then only the compiler will understand what value the x actually is. But here there is no need of giving the type of the variable. Simply you take a variable and it is dynamically allocate based upon the what value you have assigned for that variable. So it can be anything, any type of value. So that is why we can say that it is dynamic typing. Until you give the data to that variable, it doesn't assign any type of value, and the runtime it dynamically selects what type of the data based upon the input you have given. So that is why we say that the Python is dynamic typing. And one more feature in this Python is it is interpreted language. It means it has to, it will execute the code line by line. So then what are the compiler and interpreter? If you see the compiler, you have to write entire code with a systematic structure, and we will just compile it or execute it. If all the line codes are correct, then only we will try to execute or see the output. But it is not like that. In the Python, if one line is correct and the second line is wrong, then first line will automatically executes. Then in the second lines, it will show the error. That means you know where exactly the problem is, and we see the whatever the correct code we have and that corresponding output. So this is the simplest way for understanding the interpreted language. So this he's actually execute the line by line. This actually makes more simpler for doing your application. One ID which help you to see this interpretation using the Jupyter Notebook. So in that Jupyter Notebook, every line we can have one code box, so that in that we can simply execute. If it executing, then we can simply debug which line the error is. So this is much simpler for us to solve any problem using the Python code. So next one is it is also supports object-oriented programming. So like Java, we will try to use the object-oriented programming concept. Here also we can adopt the same type of features like inheritance or reusable code of whatever already have written. So this is another key feature of the Python. And as I mentioned in the previous thing, that is it actually have a massive amount of libraries for the different applications like web development, or maybe data analytics, or maybe machine learning, and you name it, you can find any number of libraries. If you see the previous sessions, we have seen for LLMs different libraries are available. You directly import those models into the Python and we work well. So it is very seamlessly we can work with the different types of libraries based upon interest of your research. Now, I would like to compare how it is different from other programming languages. So if you say in this table, I'm trying to demonstrate what are the aspects which we can compare with the other programming languages. If you see the syntax, obviously it is very simple, clean and readable with the independent based blocks. So, but if you see other languages, it is having the curly brackets, semicolons, and more complex structure you have to follow and you have to remember to code it. And the next one is easy of use, and like high level high level language means it is simply, if you see what exactly mean by high level, it is supposed to be similar like how humans are communicating with each other. So example is English language. So it more look like in a conversations, so that it is easy for you understand what is the line actually talking about. So that one is having in a Python, and also dynamic typing, and this help you to easy of use. And here if you take the other programming languages, obviously you have to take more verbose, and it's like an intermediate or low level type of languages. One example is Java. For a simple Java initialization, we have to specify the different types of data part, and methods part, and the classes, and constructions. These are the so many things we need to follow for the even simple program also. So this is another benefit of having the Python compared to the other languages. And the third one is memory management. So I think the people who knows about the C and Java, probably this topic they know. So here if you see the C language, especially when you are dealing with the linked list, so the linked list has to allocate the memory for that node, and after that, once the usage of that node, you have to delete that node. You have to free that memory. And not only that, in a Java also we will have has a one garbage collector, but sometimes you will have the packages to run inbuilt. But the thing is, you have explicitly need to collect this entire garbage and free the memory from the allocated objects. So, but in this Python, automatically it does. You no need to do explicitly to free this memory which is allocated for the object. So this is another one. So next feature is next aspect is a class platform. So that means here it is not depending on any particular operating system. You take any platform, it will work well. Suppose if you want to work with Windows operating system, it will work, and if it Linux, it works. So it is a highly class platform. So you can work on any operating system. But if you see in other languages, some of the languages will work with as a specific programming languages. For example, C# works well on Windows. So some limitations are there for other languages. But in the Python, it works well with any type of platform. And the next one is use cases, and you can do more automation or scripting or data science. As I mentioned earlier, you can use it for seamless applications. But if you see in other languages, there's a very specialized for some particular purpose. So the C language, if you see, you will generally use for the low level. Whenever you require the low level programming, and as a medium level programming, then you go for the C. So the Java is for the enterprise purpose, and JavaScript for the web. So there is a specialized programming languages for a specific task. But if you take the Python, it can help you, or it can be used for any type of application you want to do. So next one is development speed. Obviously, the Python is very fast as in it is interpreted, and it has the already built-in libraries, and has a variety of and vast number of libraries are available. But compared with that other, if you compare with other languages, other languages are very limited, and building up the libraries were little bit slower than Python coding. And here comes to the next one is community support. So here we can see the Python actually using the large number of people are using the Python, and they are very actively using actively they are using the Python. If you want to find out any debugging things, or you want to find anything, you can easily find the community so that they could solve your problem. But if you see in the other probably less activities are there with the people. The main key point here that, for example, if I want to work with any of the AI umbrella researchers, you go with most of the things were actually by the Python only. So the basic reason for this using the Python is, as I mentioned, is a vast libraries availability, and it is easy of using. These are the things make the community support. I got the more community support from the different areas of the world. So this way we can say that the Python is very easy and interesting, simple to do the coding and for the different applications. Now I'll come to the Python basics. Before going to see how the Python can be used for the different applications, I would like to give what exactly it is different from the other languages. What are the things which can be used in this Python, and how the different topics are different things will be represented or can be used in the Python. That I will cover in this one. The first one is data type. I don't want to focus much on that. Probably every faculty knows about what are the different types of data types are available for representing the data. So these are the different set of types which are supported by the Python. But next one is the string. So in this Python, probably one of the easy of using a string is, suppose if you see the C language, what we do is, suppose you want to concatenate the two strings also, you have some limited libraries, but you have to write the code. It will be very difficult to, you have to trace out the each and every location of the character array. So even though it has some of the things like a concatenation or displaying the strings, but still is a limited number of library functions are available. But here, if you see, there are different types of operations can be done on the string in a Python. One of such feature is string slicing. So this help you to divide the strings into different way. The basic syntax is like in the syntax part of the second point. So if you see that the string is having some starting point and stopping point and step. So this makes you to define your requirement where actually you start the slicing and where you have to stop and how many steps you want to take for slicing. So anyway, I will show you the hands-on for how these are going to be work by taking an example. But don't worry, now I will finish that basic information about it. Later I will show you how this code will work. The next important thing is list. So another feature which is there in the Python is we could directly initiate the list type of data into the given variable. So first of all, let me see what is a list. So list is an order collection. It will have some specific order and we can access by an index, but it is mutable. So the list is mutable means you can modify, add, remove elements after once you have created it. So and it also allows the duplicate. These are the two features of list. One is it is mutable and another one is allow the duplicates. Now it is very simple to define the list. Simply you just give a name and you directly give a square bracket so that it will automatically think as that given variable is a list. So simply I can take an example here how the values are assigned. So simply my list and you take the values by comma separated, and this will be represented by the 0, 1, 2, 3 indexing for it. You can directly access with that indexes, or we can simply whole list can be accessed. So this is the list thing. Now next, tuple. So here the tuple is also looks like an list, but it is not completely list, but it is an order collection. This is also like in a specific order and we can access through the index. But the main feature in this tuple is that it is immutable. So once you have taken the elements, you cannot modify them. So, and it is also not going to be allow any duplicates. So if you see in the previous thing, I mean, I will demonstrate with an example later. Now, you cannot, suppose if you have a banana here, you cannot have another value banana, because if once you have banana, it is one variable, it is supposed to be very unique. So, but here, I'm sorry. So he allows duplicates means, here the tuple allows the duplicates and the set doesn't allow the duplicates. Sorry for making mistake here. So here we can have the duplicates, but it is immutable. Once you have given, you cannot change the values of that, or cannot modify the values of elements of that tuple. So now, the difference between the list and tuple, how you can differentiate is here. If it is a list, you will give it in a square bracket, and if it is a tuple, you will with a normal closing bracket parenthesis, you will give to saying it as a tuple. And next one is set. So the set is also a collection of elements, but here it is unordered and unchangeable, unindexed. So, but here the thing is, even you cannot have a duplicate over there. General set meaning is it is another set of elements, and you won't allow any duplicate. So every element is unique here. So as I mentioned here in the banana, here you cannot have another banana value in this set. So that is actually difference between the tuple and set. Here the set is going to be represented with the help of curly brackets. This is a syntax how it look like for a set. So, and one more important thing which we used in the Python is dictionary. So the dictionary means it is a key pair values, and having a key and the corresponding value will also be there. So here also we were going to be using the curly brackets only, but the thing is the key and value is going to be separated by the semicolon. So now, here you see in a C language conditional statement, it looked like similar, but not exactly the same. Here, having the if and if else is going to be another condition. Here, instead of writing the if else, next if else, you will write ELIF, so that it allows you to write the multiple conditions. So I'll show you one small example for a conditional statement. Suppose if you see, if I want to find out the age which are greater than 18 or less than 18 or equal to 18. So here if I say that I will just use the if and the whatever the conditions variable you want to push on, and you will give the semicolon over there. But in the previous C language, what we do is you will open a if keyword, and after that you will open a bracket and you will write the condition over there, and you won't, and again to body of that if condition you will use the curly brackets, but here it is not required. If it is more than one statement, it is mandatory to write the curly brackets, but here you simply write the, give the some indentation, so that and scope, so we can write the multiple statements over there after the colon. So, and here see, if you write the C code, what we do is you will write if later else, and you want to have one more if condition, then after that again you will write next if. But here you can directly write it as ELIF keyword to write the multi-level if conditions. So this is how it look like. And obviously the for loop also the same. Here we will use this syntax to write, and for the first for keyword you will use, later on what variable you are putting the things, and later the sequence tells that what is the range of that particular one. So likewise we will try to use the for loops. I'm not concentrating much about the if and else because they were just like a C language, but the keywords are different and indentation is different. Other than that, the working principles are the same. So only we have to know much more about the tuple sets and list things compared to the any other languages. So the similarly, while also I just see this syntax. Here we will also similar to the if condition, we will use the colon to say that is end of the condition which we are giving for the while, and after that you will give some indentation, and that indentation tells the what is the scope of that statement executed under the while. So now this is all about thing. I'd like to show you how these simple things are going to be worked in a program. Is it visible?
Yeah, it's visible.
Yeah, thank you. So now, first, as I mentioned, see here, I'm just taking a string, and I have assigned some value to that text string, and I'm trying to apply some string operations or string sliding operations on that. So I'm just running it.
Ma'am, we can only see the slide, ma'am. We can't see anything else.
Okay, wait. Yes. Now is it visible?
Yes, ma'am.
Yeah. So here you can see that I have taken one variable text, and you can observe that, as I mentioned, is a dynamic typing. I am not mentioning this text as either a string type or integer type. Simply I'm assigning some value to that variable. Then the Python automatically consider it as a text by seeing the what type of the data you have given to that text. So now here I have taken some text information, text data into the text variable. So now after that, I'm trying to apply some basic slicing technique. And now first of all, I'm printing that original. And if I, after executing this, simply it is displaying whatever the thing is there. Now, one thing which we can observe that if you see in the C language, you have to give some percentile s or or ampersand symbol for printing those values. But here is simply you take the assign the value and simply print those value by using the print statement, even though there is no semicolon required. So here, simply here I printed that particular text which is there in the variable, in that variable. Now, the next thing is, and the first 5 characters I would like to print. Then what I do is I simply tell the first position, that index that is default, it is taken from the starting, and the next end I am mentioning that is a 5, and I am not mentioning the step count or steps which I have to take. Simply I am taking the entire first 5 locations. Then simply you can observe that first 5 characters colon 5 I have given, so it will going to give that thing. Now here I am next to see if you last characters from, this is actually positive value tells that is a forward direction. From the left to right we are counting the variables, are counting the indexes. But if you want to go back from the end of the variable means, then you will give the negative value. So here if you see this -6, then you're going to take that white from the end to the sixth, back to 6th position. So if I want to take the from 2 to 9, then that means the indexes of that 2 to 9, then you simply give this value, then obviously that corresponding locations will be displayed. So this is how you will give the slicing. Now if you see the step slicing, and now the third parameter I want to use, then simply I'm not mentioning the first and second, means this entire variable I am considering. So and the step count is 2, means every 2 variables are going to be printed. So like hello and Python for the every given variable or a given word. So this is how it is going to be taken for the things. And now you want to take from the reverse thing, then the -1 is going to be taken. That it removes the first particular thing, and it's trying to provide the display the thing. So this is how the slicing works, and you can practice with the different values and verify that how the indexes are tracking or indexes are printing by taking these 3 locations, starting and ending and step count. So this is the slicing. And if you see the next one, now I'm creating the list. Let me take the different things I could include first. So now I'm creating the list. So whenever I give a square brackets, it automatically treats it as a list. So I'm just assigning the list here. Now I want to print this list. I simply give print roots. So you can see that. So here the fruit is a list name or a variable name which I given for the user defined list. So here I'm having the 4 elements and each element is an ordered one. And if take the fruits of 0 1, then it will take the apple, and the fruits of 1 banana, and so on. So if I want to see that how I can append the values into this particular list also we can see. So here I have taken orange and I have appended to the list, then automatically this orange is going to be added at the end of the list. So, and also we can remove the list. We can also use the remove method, and with the help of that you can pass the what the element you want to remove, then automatically you can see that thing. So after inserting and removing, I can see that updated list. So if you see these two are already executed, that's why the orange got removed from that list, and orange got appended to this list, which is actually given previous list is going to be added with the orange. And after that I removed the banana also, that's why the second element in the previous list was removed. Now the updated list will be like apple, cherry, mango, and orange. This is how we can do. I'm just giving the sample methods, and likewise you can also see different things, like simply taking So if you want to see what actually can be done with the fruit, what the variable. So if you want to see what are the variables or objects or functions are assigned to that particular variable, you can see by using different by using the dir function, we simply see what it is associated with. See here you can see the remove method in that, and sort, reverse, index, extended, count, clear. Likewise you can see the different things, and here also having the different other functions like delete item, doc. These are the different other type of variables which we have in the dir. So this is all about the dir trying to tell that if you take any particular object in the Python, what exactly it can be done is going to be known to that. Some of the applications you simply put the cursor over there, also it will display what are the variables, functions, or objects can be accessed through that particular variable. So this is one easy method to understand whether I have that particular function or not, or I can have the particular variable for that given object or not, can be simply understood. So that's why I simply used only the remove and append function for demonstration of that particular list. So simply for not only the list, if you take any variable, you can apply the dir, then you can display the what are the things which we can done with that particular variable will be displayed. So now I'm also trying to explain now how the tuple is works. Now let me compile this. Now I created the colors variable. As a type of that variable is a tuple, and the tuple means here I'm using the braces parenthesis we say. So here I am using the 3 elements, and here it is tuple, but we can have the duplicates over there here. So now, but here it is immutable. Once you have given, I cannot change this particular values which I have given. So this is thing. Now I just move to the next set one. So here also see that I have created one set over there, and I have given the set values in the curly brackets, and I have given 1, 2, 3, 4, 5, and 2, 3. Now the 3 is duplicated here. So if I want to print this particular one, then here automatically I will show you how it will look like. Let me have one more code. Cut the cell. Video. Wait, sorry. See here, I have taken the numbers, and here I have given duplicates in the values of that numbers. But if I printing that numbers, it actually automatically this duplicate values got removed. So this is how the set works. So the set only takes unique values. The each element should be unique, and it won't allow the duplicates. So you can apply the different things on the sets, and we can add, remove, or any operations can be done on the given numbers. So this is how the set will work. So now you see the dictionary. Now I would like to create a small dictionary, and let's see that give the values. Now I have taken a one person name for the given dictionary, and I have given a name as actually key, and have given a value for that key is Alice. So likewise, I have taken the three keys and the corresponding values. Now this colon will specify that what is the key and the corresponding value. So I can simply access those keys with the help of given by like as accessing with that the key constraint or key attribute. So simply I can show you how actually it will look like. Now suppose in the first statement is I'm trying to print name equal to person name. So that's why here automatically one name is there. Suppose if you have the multiple things are there, then you simply put a comma and or separate records you can give, and automatically it will take that. So here that is actually necessary how these things are going to be accessed. So now as of now you can observe that for the given names how the values are going to be assigned. So after here you can also modify that values by taking the specific thing. I mean, if I want to modify the age is equal to 26 instead of 25, then simply I can access the person value by using the key age. So simply even the country also. So the general convention for the values are, if it is a string, then only whether use the single quotes or double quotes for accessing them or storing them. If it's a numerical value, there is no need of using any single quote. This is a general convention we used in a Python. So now this is how the things were. Now I will stop the basics here. Now I will come back to the PPT, which actually shows how the different libraries are basic libraries which are required to do any programming. I mean any ML or any other application programs which deals with the numerical values, list or mathematical things. So that I will explain through this PPT. So then I'll come back to this demonstration after finishing that presentation. Now, is it visible? The PPT is visible? Is my presentation slide is visible?
Yes, ma'am.
So now I'll start a library that is very important for the numerical operations that we call it as NumPy. It will supports the large and multi-dimensional arrays. Generally, we take the 2 dimensions, then obviously the matrices. Most of the time when you are dealing with any researchers, 2-dimensional data we probably use. So more than that also it supports. So it is very much important when you are dealing with your research problems. So you can say what exactly the NumPy does. I mean, we will see now how it actually works and what makes it is to deal with the array. So here we not only storing data in a multi-dimensional way, it is also going to provide some mathematical functions so that it will completely apply on all the data, so collectively. So how this actually makes possible is it will use the nd array object that is actually helping you to give the more operations on in the billion list. So here simply you can apply on all the elements and element wise. So you can do multiplication, addition, and many more operations on that particular list. So let us see how actually you will create the numpy type of object. So first of all, you need to import that numpy. Sometimes if you are starting I mean initially after installing the python, you want to work with that, obviously you need to install this numpy package into your python. So after that only you can able to access it. So you simply using the pip command, you can install that numpy, and you can simply import an numpy, and you will give some object name here as an np or some other user defined names. That's up to you. So after that you have to access the functionalities provided by that numpy is by using the dot operator, and you simply use the array of those particular list. Now I am passing this single dimensional list in that. So suppose here if I want to perform a multiplication on each and every element, then I simply what I do is print array into 2. That automatically does the multiplication of multiply 2 for each element. Now the obviously the updated element will be 2, 4, and 6, 8, 10, and so on. So it will apply simply on every element, and element wise operations can be done with the help of a simple code like using array into 2. So this much easy to deal with the numpy. Suppose here you may think that is a simple thing, but if you take the data set, it is having the lakhs of variables, then you cannot run like 1,000 iterations to multiply that. You simply give that array name with some operation, whatever the operation you want to perform on each and every element, then automatically it does for you. Now, and more very much important a library which we need for any problem solving is pandas. So especially for the A&ML or maybe data analytics or any scientific problems, that pandas very much helpful. So this basically help you for the data manipulation and also analysis on that particular data. So it also provide, how this make more efficient for manipulation analysis is it provides the different operations like filtering, grouping, aggregating the large amount of data. So the basic thing is it will take this the data is like a series of the data. So one dimensional array like an object using this using the single column for the data. Likewise, every column you want to visualize column wise and record wise, everything is seamlessly you can access the data, and you perform the operations on that particular data like merging, joining, filtering, and reshaping the data. So we will also going to see how the pandas will help you to visualize your data when you are doing the exploratory data analysis. That also I will going to demonstrate in this session. So this help you to see your data in very efficient way and describe your data, and you analyze what is the there in your data and how to store your data in a systematic way for the further machine learning or any analysis part. So now I can show you how this actually look like. Now similar to the numpy, we also has to install that particular package that we call it as pandas, and using that pandas you have to import the pandas using user defined variable name like a pd or any name. It is not supposed to be always pd. You can take any user defined name which you like, and you simply give some data variable to the what type of data you want to give. Now you see that here name is there. Now for that name you have the 3 different names were given, means there are the 3 records for that particular data frame. So now for the age column you have the 3 corresponding ages of the John, Anna, and Peter. Likewise you can give the data. Now it is just look like a 2-dimensional data now. So Now the simply this data can be make it as a data frame, so that it will give the series of the data and indexing for it, and actioning the grouping or filtering operations can be done. For that, you simply assign this uh, entire data frame into some object, like using the df equal to pd dot data frame of that particular data which you want to pass it. So using this function, you can simply make this entire thing as the series of data, so that we can do the manipulations on the given data for the different operations. So this is how the pandas work. So now now I'm now one more important library which has in Python is math library. Obviously, for any scientific operations, you need mathematics. So for that, there are different libraries or functionalities are there with the help of the math, which actually provides the basic arithmetic, trigonometry, logarithmic, and or maybe some of the constants, and you can name it. You can have the more number of mathematical libraries are available. By simply taking that functions, you can get the mathematical equations done. So some of the basic things which we can say, like a square root or power and absolute values, ceiling and flooring, these are the things which I'm just for the understanding purpose giving this one. You want to see that, you just create the object for the mathematical library, and you see how much operations can be done, what are the different variables it can be accessed through this math. You can see, you can simply apply the dir on that variable, then you can understand what features are going to be provided or what functions are going to be provided by this mathematical library. So not only these basics, and also like a sign of something or cos operations, a different built-in functions can be applied on the trigonometry or logarithmic also it can be. So simply how we can use is simply import the mathematic, or you can create the variable using for the math type. So here I'm directly using for the simple mathematics. So simply use the math dot square root of 16, then automatically it does and provides the output. So this is how we can use the mathematic. And the similarly the statistics also, when you want to see the mean and mode of the given data, or standard deviation or variance of the data, how your behavior of the data look like in a given data set, then obviously you can take help of the statistics. It directly provides the different operations which are there in the statistics. So this seamlessly you can access those operations on an entire data set. So these are the mathematics things. Now one more important library is that matplot. So this is the library used for plotting your data. You want to visualize your data. So what actually my data look like, and what is the my data behavior. So obviously by seeing the curve, we could see how it is actually the behavior of data, whether it is in a normal distribution or it is in a simple linear fashion, or you want to see the data plotting, then we use the one basic library is matplotlib. You simply uh, use this one for the visualization of entire data. So it can be provide the 2D plotting like a line, bar graph, histograms, or you can also use the customizable 2D graph, like how you want to represent each point, and what is its color, and how you can use the legends. You can also pick with your customized way, but it help you to give the good picture of 2D picture of your data. So these are the some of the samples variables which are there, but you can apply dir on it, so that you will came to know what are the different functionalities available in it. So this is a sample way how the x label can be defined, or y label can be defined, and how the plots are going. Now one method which I would like to say is, here the plot actually takes the what is the x-axis values and y-axis values, and it automatically, the plot method will show you the entire graph for it. So this is how it looks and how it works. So one more library which is actually on top of this Matplotlib that we call it as Seaborn. It is a more scientific graphs can be generated with help of that. So now so it is actually it's like an visualization purpose only, but it takes more complex operations than the Matplot. So you simply you want to draw the interactive or statistical graphs, then probably the Seaborn help you more sophisticated way. This is the different libraries which I'm going to show you with the small examples. Now, I think it is true that I'll take a break, a 5 minutes break, then I'll continue with the remaining things with the help of a programming. Hello. Hello.
Yes, ma'am.
Yeah, you take a 5 minutes break and come back at 35 to 35. Can I start now? Yeah, thank you. So is my program is visible? Notepad is visible? Yeah. Yes. Now, for the continuation of the previous presentation, now I'm going to show you how this NumPy or pandas or math and matplot statistic libraries works with a simple example. Now I'm trying to execute this NumPy. Now here we can see that after installation, already this NumPy pandas are all got installed in my Jupyter notebook. But simply I'm actually importing those libraries with help of my user defined object name. So here I'm just imported that NumPy as NP. Now I created my array so that I can perform operations on. So now that array equal to np dot array of some variable values I directly pass to my object. Now I can apply the mean of that entire thing or standard deviation. Even I have mentioned that the statistics also we have, but mathematics also, I mean normal mathematics are the statistical simple statistics also we can apply on the NumPy. So here whatever the operations we want to perform, you simply use that object name dot that function what you want to perform. So you can directly observe that here the mean of this entire array is actually 3 and the standard deviation is 1.4. So this is how we can simply apply whatever the operation on a given array. So now you can see the sample pandas as I have shown in my PPT. Now the simply I have imported the pandas library. Now I'm just running that one by taking that frame. Now you can see that the data frame and indexing is going to be assigned to that one, and 0, 1 to record and attributes name and age. So now it has 3 records for the indexing 0 to 2. And now I have also applied some operations on that. So this object is df on age I want to perform. That means the first column, I mean second column of my data frame I want to find out the mean. Then simply I can take the df of so and so attribute name dot whatever the operations I can perform on it. Now simply you want to see what are the operations or variables I can access through this pandas. Is you can simply you apply the dir and df, so you can able to see all the operations or parameters you can access or the operations you can perform on Am I audible now?
Yes, madam.
Thank you. Sorry for the interruption. There is a technical issue, so that's why I am able to. I mean, I disconnected from my presentation. So I'll get back to the thing where I started. Give me 1 minute. Are you able to see my window?
Yes, madam.
Thank you. Now I'll continue the thing. Now I can simply execute this mass function using math dot different functionalities available in the math library. So now I also similarly the statistics also. Now I took the array of data, and here I'm trying to apply the statistic operations on the data. The simply I will trying to use the mean, medium, or standard deviation on a given data by taking the simply. Now here the statistics also you can directly create a variable name using the as keyword, and also you use the name for the purpose. So now next, I would like to see how the matplot works by taking the different variables. Now, the sample data actually, you can see that actually the x-axis points are 1 to 5, and y-axis points are 10 to the interval of 10, and some are the 5 like 10, 20, 25, 30, and 40. Now, I'm trying to represent this data in the form of a graph. Then I simply use the plot method, and I just use the PLT as a variable which I have used matplot pplot functional. So now using this plot dot PLT dot plot, I'm just passing the x values and y values, and what marking I should use for pointing that x corresponding to the y, and connected with these points, what line marks I'm using. Here I'm using the dashed values, and the color I'm using is red. That's why I'm making it as red, and label is I'm just giving that legend as a dot dash, and here the name of that legend is data. So now how I will try to use by using this plot I could see. Now I'm also giving some parameter values for this one. So simply the x label as x-axis and y label as a y-axis. That is the name which I'm giving to the my x and y axis, and simply I'm also giving the title of the plot by simply saying the simple line plot. So and now I'll plot the legends, and also I will show the thing. Now after plotting this one, I have to see that diagram, then or a picture or a graph. I could use the plot dot show method. So if I run this automatically, my data is going to be plotted in the form of line graph. This is how matplot works. So this is the basic libraries. Now I will move to the PPT. Then these are the basic things which we need to know before going to start with any scientific computations. So if you know this one, probably it is helping you to write the code efficiently by using the more sophisticated libraries for scientific computations. So now I'll move to the PPT. Then I'll show you what are the different libraries are used for the scientific calculations. For example, now the context here is it is a machine learning. So how the machine learning uses such libraries to perform computations using the different data sets. So now I'll move back to the presentation. Just give me a minute. So, Now, is my presentation visible?
Yes, madam.
Yes, madam.
Yeah. Now, one library which is helping you to for all the scientific calculation that we call it as scikit-learn. This actually provides the so many machine learning algorithms or any scientific calculations. Now, I will try to show you what are the prerequisites required for performing machine learning.
Ma'am, can you hide the pop-up? No.
Now, okay.
Yes, ma'am.
Yeah, thank you. So now I have different libraries. Now that is why actually why I have shown you what is the pandas, numpy, matplot, seaborn. So these are the prerequisites we need to know before going to start any scientific computations. So as I mentioned, the pandas, numpy, matplot, seaborn. I already told you what is actual meaning of these libraries, what are the functionalities of these libraries. Now here another things is data sets. Now the data sets are available online, as the earlier session was mentioned that there are the different repositories are available. You can take in data from that repositories. Now you are a beginner, you want to try something and learn the scientific computations, then the Python itself provide, the sklearn provides certain built-in data sets. You simply access those data sets and you can work on for understanding of scientific computations. So they provide the some of the inbuilt data sets by this library. And what I'm just giving some of the algorithms. These are not only the complete picture of the Python, because you cannot cover all the libraries in a one session. Is a huge number of packages are available, depend upon their area of research and area of interest and the type of the computations you required. Even for the small applications also they provide the different libraries. So dealing with the text data, different libraries will be there, and dealing with numerical values, there are different libraries are available. Likewise, depends upon the type of the data and the domain which you are working and the type of computations you want, you will get those varieties of libraries in the Python. Now in this context, I'm trying to provide some of the algorithms, like how you can access them from the sklearn. So here I'm trying to tell that linear models like linear regression, you can have it from that library, or support vector missions you can access, or other random forest or gradient boosting classifier. This is the certain some of the algorithms which I can name it, but more than that you can go, more number of algorithms are available in sklearn. Scientific learn. So now here the beauty of the Python is that here no need to do all the procedure manually. So whenever you are talking about the ML, as the first talk we came to know that first of all you have to collect the data, and later on you will split the data into training and test, and you will train the data, and later on you will test efficiency of your algorithm on the test data. So, and you want to see the accuracy, whether you have met the correct accuracy or not, you achieve the accuracy. Accuracy means is how best it is working, whether it is really matching with the human accuracy or it is really matching what we require. So these things all can be done simply by importing the libraries from the Python. That is actually that is why actually I told that Python is very easy compared to the any other language. For that we will use the model selection library. In that there will be different types of functionalities are available. Like you can
no need to split the data randomly for the training and test set. You simply import train and test split method, and that class you can use it for your dividing the data set. And also you can cross validate the scores, whether efficiently I am able to do or not, or whether the training is correct, correctly trained it or not, what is the efficiency of the training. Those all things can be done from these model section libraries. And this is also belongs to the sklearn kit only. And you can also see the metrics. The metrics means which are measures to compute the functionality or accuracy of the given machine learning algorithms. So that using those metrics class also we try to find out the mean square error, or find out the F1 score, or precision, recall. These are the metrics can be accessed directly with the help of these methods. So you want to see the things, you can simply click on this, and you can find out thing. Now trying to so here if I click that symbol, now you can see what actually different types of functionalities can be provided by the scientific learn library. So you can see that classifications you can apply, and the regression functionality is available, and clustering available, and dimensionality reduction is available, and model selection available, pre-processing of the data. That means you need to be get ready with the what actually we can train the model. Whatever the data available, you cannot simply give it to the machine learning, because the data having much noise and incorrect data, or maybe the data which is actually not corrected to that, and some of the missing values will be there. So these all things has to be handled before to the training. So all this pre-processing technique is also available in this library. Likewise, you want to know much about this one, simply you can just click that particular one. You can extract what are the different methods available in it, how it functions, what are the different ways of accessing those methods, and the syntax. This manual provides you complete information, how to use it, for what you have to use for and how what are the syntaxes for this. Everything is available in this thing. You can note down this link so that you can access it further. So because we cannot explain each and every functionality provided by this one, you just, it depends upon your requirement, you can simply go. And it will provide the different APIs available, and the different examples also they will provide, and the communities you can go and ask and connect with the other people, the blogs, so that you get a help from solving your problems. So this is how we can go with now. So now I'll move to the presentation. Sorry, I think it has. Now I would like to show you how we can visualize the data before going to apply the machine learning. For that purpose, I'll take one more thing. One more program, so that I could show you how the data can be visualized with the help of a small code. So that we call it as exploratory data analysis. In this program, my agenda is I'm trying to load the data, and I will see what the data is there in my data set, and how I can see what type of the data I'm dealing with, and what is the nature of my data. These all information I need to know before going to apply any machine learning algorithm. For that purpose, I'm trying to use this one. Now, one thing which I need to do, I'm using the Google Chrome, Google Drive. So for that purpose, my entire data set is loaded in the Google Drive. So I'm going to import those files into the Google Colab. That's why I'm just taking this code to collaborate my drive into the, or to access my drive into this Colab application. So I'm just, give me a minute. It takes a minute to connect with my drive. So I'm just trying to. Now the tick mark specifies that is mounted successfully. Now I'm trying to run the libraries, different things which I need. You can observe that I have used the pandas, numpy, now the operating system library, so that I could give an access to the accessing of my OS files. But now in this you may not require, but generally these are the normal libraries which we will import while we are doing any exploratory data analysis. So now I'm using the matplot and data sets like sklearn data set for the classification and the linear regression and modal selection, as I mentioned in the earlier slide. And the metrics also I am trying to access, and the confusion matrix. This is the where actually tells the how many true positives or the classification are true negatives or false positive, false negatives. This things will be they come directly by using this confusion matrix. And you can also see the classification report if when the classifications and what is the accuracy scores. All things simply can be simply just importing to that. So now I'm just trying to load my data here. That is a CSV file I'm loading. So I already loaded. I'm using the read CSV function so that I can access to this CSV file and storing into the PD. PD means it is a pandas data frame. I'm just loading my entire data into the pandas for the training. Now I want to see how the things are there. And before that, what are the things I could do with this trainees? I simply run the thing. Then these are the different functionalities I could access with my data frame. Now the next thing is I want to see the shape. That means how many rows are there and how many columns are there in the data. So I simply trying to use the shape variable, and the shape functionality will tell you the what is my shape of the data. So now I am having the 16,000, 1,60,792 records are there, and each is having the 3 columns. So this is my shape of the data. So that means it's a huge data which I'm dealing with. So see, even if I want to load it in the even Excel sheet in the normal system, it takes much time for us. But here, see how nicely it is assigned all my CSV or load entire CSV data into the data frame. So now I want to see the information about the given thing. So what exactly that information means, how what is my columns are available and what is their names and how many values were there for that column, what is the count of any null values are there, or what type of the data it is. So I want to see, simply I'll run this. So you can see that I can see that the number which is actually taking what are the number of columns I have, and the column names in this second column, and how many records are there for the each column, and what is the count of that particular one, and whether what is the type of this data. And likewise you can provide, it provides the brief information about your data. So now I'm trying to see is any null values are there. As I mentioned, when you are applying for the machine learning, you should take care of that there is no null values in that. If null values means features are not defined, so you need to define those features. For that we have to verify. Then how could see that how many null values are there? So then I simply apply the isNull function on my data, that is trained data which I mentioned. Now simply it is fine all the values. So false, this value tells that is a false. So now if it is true means it is the null value. Now I want to see the what is the actual values existed in my given rating, given column. For example, first of all you want to see what is this data. Let me print some of the data here so that you will understand what is the meaning of this particular thing. Before that I will print the head of my data. Now train head. So, So this is actually my data look like. So I simply head means it provides the few records are top 5 records of my data. Now this is actually, even though I have the 1,60,792 records, but it is showing the first top records so that I could see what is the values which I have. Now in the reviewer ID, this is an object or it is some string value is there, and item ID is another value, and the rating is there. Now I would like to see how many different distinct values are there for the rating. So then I will see on each value how many are there in the given data I would like to visualize. Then I simply write that train rating. The train of rating means this is the data which I am giving the name, and the rating column I would like to visualize what is the value counts. So then it will say that in the rating column I have 5 rated columns are 93,526, and 4 ratings values are 32,000. So I could see that. Now I can visualize that what is the topmost values which I have is almost 93 records having the 5 value in a given data set. I can see that. That means if I say 5 class is a more prominent class, in that I have the more data with the 5 class label. Let us assume if you consider this rating as a class label. Similarly, you can also see what are the different item values are there. Now this item ID have the 780 and so on. The least value for any ID is this particular one. So this is how we could see all the things. Now I want to normalize what is the percentage of the values between the thing is. So I simply give the count value normalize so that I could see what is the proportion of my entire rating value. There is 100% of the data. So this is how we do is rating values. Now, so now I would like to go further. So this is the visualization of my data simply, and you can even do the more number of analysis on that. Now I directly go to the thing how the different machine learning algorithms will work for that. So now I will take the KNN. My intention is here not to explain what is the machine learning. Probably coming sessions they will explain you what is the supervised learning and unsupervised learning. But now I'm trying to help you, or trying to understand you that how a machine learning algorithms will be executed by with the help of the scientific learn toolkit. So now I will take this KNN algorithm and an example. Now I will show you how these things will work. So now I'm trying to load the things like try and split thing. Now the KN is a classification algorithm. Basically, it trying to find the K nearest neighbors. Based on that, it trying to predict the values which are nearer to my given class. So now, just it takes time to load the things and load the drives also. Now I'm loading my drive so that I could continue with the. So now I'm loading my data in the data frame by the data which I'm considering is diabetics. Now that information I'd like to see these are the things which I have in my data. There are 9 columns are there, and each are integer. I mean the BMI and diabetic pedigree function is a float, and remaining all are integer values I have. Now this is my thing. Now I would like to see what actually look like. Now this is the information actually look like. These values are actually thing. Now this outcome is my target label. Now I will train my model with the sum of the training samples, and I will take that these are all are actually features. Now the last outcome is the target label. Now I will give all these inputs, then I should able to find the what is the outcome of the thing. The outcome says 1 means it is diabetic is positive, otherwise negative. So for that we need to train some of the data so that I could fix the function, and I could able to fit more all the training data so that I could predict the features for the upcoming instances if which are not known to the training data. So now for that purpose, I need to split this entire data into training and test data. So for that, I'm just simply using this train test split. So this function will help you to think. Now, when you are splitting this one, you have to see what are the parameters I am passing. First of all, the X train is nothing but you have the all the features of the given training data, and the X test is test data features. So Y train means the labels of the features, and X train labels are going to be defined in the Y train, and X test labels are actually given in the Y test. For that purpose, you have to pass this values to that particular one. Now here if you observe that training and test, we are not passing any output values, only simply that means outcome value we should not pass, only the features. So those are from the first one to the up to age only I have to pass. That's why I'm making dropping of this particular one outcome, and I'm passing the first 8 features of that particular one, and later I'm only passing df of outcome to split this Y train and Y test. So this is the first 2 variables. What is the X value you have to pass, and what is the Y value you have to pass. So this entire data frame is going to be fed to the X test and X train, and will divide into 2 parts. And this df of outcome is actually going to be given to the Y train and Y test, and it will divide into the 2 parts. The now next question is which part is how much. So now for that purpose, I need to mention the size of that one. So 35% means I am taking the 65% as a train data and 35% as a test data. So now the next one you will remember is a random state. This random state specify that we have to remember the what random values you have considered, so that if you execute next time also, it will give the same type of selection of the records will be preserved. Otherwise, you take the different samples, and you will get a different accuracy. Then you cannot compare the first running to the next running. So this is all about the environment of the dynamic environment. You want to store the whatever the samples you have taken for the train, the same sample will be taken for the next running of this program. That is only the difference. Other than it is not having, even though if you're not given the random state also it functions. So now after that we need to normalize the data so that it will be helpful for giving the best training, and you can fit the data into the machine learning. So now I'm just running this one, that is actually using the standard scalar. This is a normalization will apply for the both X train and X test, so that all the values will uniquely distributed between the sum scale of the data. Suppose my data is different 0 to some thousands, then I want to make my data into from scale from 1 to 10, then I will just give that normalization. So all my data is just to fit into my 1 to 10. This is what I can simply say that normalization means. So now the next part is, this is all actually I prepared my test and training data. Now I have to do the thing that, so you need to create an object for this one. Now I have to call the k nearest neighbor algorithm. Now I just use simply by importing the values. Simply I can drag this one as I have imported that functionalities in that. Now I will run this one. So here I could see clearly that this classification actually taking the 5 neighbors for doing the k nearest neighbor algorithm. The k is equal to 5 I have chosen, and now I am using the function fit. This actually, the fit function help you to train your entire data. Now if you know little bit about the machine learning, in the machine learning what we do is, when you are training the data, you will give the features and the labels also, and when you are testing the data, then you will only give the training variable features, but you won't give the the labels for it. You have to predict the label. But here, the fit function actually used for the training your model. Now, for that purpose, whatever the training data we are giving, the features we are giving as an input, and also the labels for that trained data also I'm passing to that function, so that it will give the boundaries. It will try to find out the boundaries for the different classes, so that I can predict the unseen data later. So now I'm trying to, the next third step is, now after training this one, my model is ready for the running. Now I will try to predict the points which are stored in a X test, so that these Y values are going to be predicted. Now the question is, how accurately I'm going to predict these values can be used by checking. Suppose here the Y test already I have the labels. Now the Y predicted is my model predicted things. If these two are matched, then accuracy will be 100%. Otherwise, how many percentage is actually matched, we could able to see with the help of the accuracy function. You simply run this one instead of simply calculating manually how many are really classified correctly and not classified correctly. We simply just use the method accuracy score, and this will give you how much accurately you can classify. Now for the accuracy 71% is nothing but, now the 71% of the labels were correctly predicted by my KNN model, and remaining 29 are actually misclassified. That was whatever the predicted was wrong if I compared with the real Y test data. So this is how we will do the things now. So this is the thing. Now I'm trying to see if I choose the different case, how my KNN algorithm is functioning better. For that purpose, I'm just making it a loop from 1 to 11 range. I'm checking every K. First, I will check with the first K. K1 value is equal to 1 until the 11. I will compare and accuracy, and so that I will choose the what is the K parameter which is giving the best result. So I will run this one. By seeing this one, I can say that this accuracy with the 3 K is equal to 3 and the K is equal to 5. So this is the giving thing. Then I will fix that K is equal to, this is one method to fix the K value. Other than, you can have other methods also to choose the best K. So this is how you can apply these train test split for dividing the data into train and test data, and how to apply the machine learning algorithm using creating the object of that particular classifier, and using the fit method and using the prediction method. This is how easily we can, even if the people who doesn't know about that particular classifier, also with the help of the things, if you know the basic knowledge about how to use them, you can simply apply the KNN algorithm on a given data, even a big data, large data or a small data, irrespective of that, we can apply seamlessly with the help of the scientific learn toolkit. So I hope understood how the Python make you easy to run these machine learning algorithms with the help of the inbuilt libraries or scientific libraries. So similarly, I'm also going to show you how the clustering operations are going to be done by the Python. So I'll take one more program to demonstrate how the k-means algorithm works for clustering by taking the thing. Now I'm just taking the cluster module, as I mentioned in the website. You have also use sklearn for clustering. So I'm taking the k-means algorithm and just importing the k-means functionalities or k-means algorithm by from the sklearn toolkit, and now I'm importing the pandas, and you can see that the pre-processing also I'm taking, so that I could use the pre-processing of my data, and I should also using the matplotlib to see how my data is distributed in the graph. So now I am running this one. So now again I'm taking the data from my Google Drive. That's why I'm connecting to my Google Drive. So now I have added the bank details so that I can apply the k-means on the bank things that I would like to group the people who are having the similar. Yes, so that's why I have using the CSV file, which I have stored in my data frame and with the name of the data. Now I would like to see what actually my data. This is my data. Now it is having the 41,188 rows and 21 columns are there. That means 21 features are there. Among that one, when you will apply the clustering, if you don't know the target label, what you want to find from the data you don't know, then we will apply the clustering approaches. So here we can see all the 21 as a features of my thing. Now I would like to group them based upon some similarity. So now I would like to, before going to apply this one, I would like to show you the different EDA things. Now I'm just trying to see the shape of the thing. For that, I have 41,188 records and 21 columns are there, and is the is null is there, then what are the null values I have, and just summing up for the each attribute, and the zero values, zero number are there. So now I'm trying to also see the information about the data by using this dot info now, and I'm only trying to consider these following features only. I'm picking up the features. I'm not taking entire 21 features along, only the names which are listed here I'm considering. So I'm keeping one more data frame that I'm checking as catalog columns and the category columns. Why I'm doing this is I'm just pre-processing. Now if you take any mathematical algorithms, you cannot give the text data, so I need to convert them into numerical values. For that one, I have to take this categorical information so that I can transform this categorical information into some numerical value. For that, I'm just simply taking the only fixed information from the given data, because these whatever the names which I consider, those are all object means they were not integers. So now I'm taking those picking up those things, and I'm just pausing all this thing into the data. Now the data is reorganized into like this. So only I have considered the job Marshall to the subscribed data. So this you can see that now. So simply want to see a specific column, then I simply data of the particular column name if I give, then it will also displays, and it won't display all the values because this cache memory will be very less. If I want to store the lakhs of the things which cannot be able to fit, then that's why it will give the sample starting and the ending of my data. If it is very few, then it will display full, otherwise it will show you like a dot, so that you can see the range of the indexes with the help of the outcome. So now I'm trying to convert these all things into a numerical values by using the dictionaries. Now you can see we have discussed in the previous our discussion that the dictionaries are also very much important for us, so that I can make this or map these key values into some other value, so that I can able to remember these things. If I say in the first column, if I say housemaid, that value I am assigning is 0. So whenever the 0 things, then if I am reconverting the data into normal data or original data, then I can say that if the 0 value means it is a housemaid. So likewise, I remap the values later. But now for the computation purpose, I will just use conversion of those categorical values into some numerical values with the help of the dictionaries. Just I am simply applying and replacing those values with these key values. So I simply applying this one. So now if I see my data after doing this one, see how initially the data is in the form of categorical. Now these values are converted into numerical values. This is how you will apply the pre-processing before going to give your data into the machine learning algorithms. Now the original work starts to ready for the clustering. Now I will simply write a model k-means, and I will just create an object for the k-means algorithm. So for that purpose, you need to know uh, how many clusters you want to perform and what the random state we will take so that I could repeatedly running also we get the same type of the samples will be spreaded or randomly selected. So and this is automatically I'm considering existing algorithm. Now I will run this code so I could create an object for this. Now simply how we have done for the KNN, the same way here also I will use the fit method so that I can fit all my data into that model so that I can train my model for the given problem. Now I simply run this one with data. I think data some error is coming. Yeah. See here, here I'm trying to consider now after fitting this one, it is trying to show that it's already, if the no error means it is already fitted my data into that model. Now the specifications also it is showing on the thing by saying the number of clusters is five. So now I will try to see how those are the clusters were, how many clusters we have considered and what is the mean of those clusters you want to see. Then simply I will see that my model dot cluster centers and the columns, what are the columns we have considered. Likewise, we will simply giving the names with these clusters also by class B, class C, but that are going to be assigned as an index to these data columns. Now we can summarize what is the means of these clusters and the each variable mean also we could see simply by taking the cluster centers function. So this is the values which we got. Now I will see how many this is series data which we have and how many are there for the given values for the four classes. I mean fourth group we are having these many records and the zeroth group we are having zeroth cluster we are having these many values. I mean and likewise each cluster how many data points were grouped is going to be shown. So this is how you can see how the clustering is going to be happen by pre-processing the data and seeing the what values they have. So this is how we can do the machine learning by using this scientific tool. Now I'm going to show you how the different data are going to be accessed and how the data can be stored into the thing for the different types. Now, still now I have only shown the CSV files. Other than that, you can also load the JSON file or text files you can visualize and any type of the data. The libraries are available simply by calling that function. You could load your data in any format into the data frame or any list form which depends upon the structure of your data. Now I will show you that sample also. Just give me a minute, I'll get back to that. See now, along with that thing, how the data actually loaded into the thing, and how you can access the drive or to the Google Collapse. I'm trying to give things, and now here I'm just having the data .jsn file. Now the JSON file I'll load. Let me. Right. See now, my data is in this particular folder. Just I will try to see, copy that file name, just like that, copy path. So I just mentioned that now. Just give me a minute. It is. See. Actually, I'm trying to load this one, my the patio.jsn file, and the path I have to store. Now, once you have loaded your drive, then you just go to that particular path, and my file is here. Now, I simply copy the path and I have pasted so that it is not in the local drive. So you cannot directly open that file. So I need to give this complete content of your drive. So, and the complete path I have mentioned, and I opened it one. Now here what happens, each token is going to be used by using the JSON load function. This is actually help you by importing the JSON file. So this package help you to deal with the JSON. Now here, if you see this load line, each line will having different files. So I'll just show you how actually the file will look like in the line wise. I will show you in the online itself. So I will open my JSON file. Sorry. Yeah. See here, my each record is going to be represented by these flower brackets, and now here I am having the different fields like review ID, ASIN, and reviewer name. Likewise, there are the different attributes were mentioned. That means there are different columns I could say in terms of two-dimensional data. So now this each line having these many things. Now I need to take those fields which are required from me. Here, let us assume I need reviewer's ID, and ASIN is nothing but item ID, and overall rating. I want these three things I want to show, and also the review, also text review, also these things I want to load it into the CIC file by neglecting the remaining fields. If you want to take, you can also take those fields by using this code. So now what I am taking is I'm simply text one. I am storing it as tokens of the reviewer ID. So here the actually all this if I simply load this particular line, it will show you, I mean it will assign automatically how many parameters are there. Here it is showing that it having the 9 tokens, 9 items are there. So among those, I am choosing the field token reviewer ID, ASIN, and overall. So the three fields, and you want to add some more thing, you simply take one more variable and assign that. Now, the finally, I am trying to concat these values into a simple header file, and I'm just going to append into the my list. So now this first one thing is, first of all, I will make it as a list by concatenating all these things. That function was actually written here. So this is simple code to club all these individual files into a simple list. So now that I am appending, likewise I will take one more CSV file so that I could write this entire thing. So patio experiment .csv. Now I'm writing, and new line is going to be given, nothing here. Now this is actually how I'm writing this file. Now the simply the writer is equal to cs.writer of the file. This is the function which I'm going to use it to write the given each by line into the CSV file. Now I will simply all these things are going to be written onto the files by using the, and just passing this list one to this writer object by using the write rows. Now I can simply just running this one. So after this one, automatically I can get a exe file with the same path. I'm not mentioning path again. I will mention the path here so that I could visualize the things again. So let me, so I'm just giving the path so that I could see the file after writing. See here, automatically patio x file is actually written and created by taking the each values. Now if I open this file, I could see what the values has been. See, you can observe that the ID I have taken and the values are stored, and I reviewer ID and item ID I have taken the one by one value, and the rating is actually taken. Now the whatever the JSON file which I have seen completely transformed into a CSV file. Now I can give this file to my machine learning algorithm so that I can apply some machine learning approaches on, and I could get the required functionality. So this is how a particular JSON is going to be converted into CSV. So you have to do is all this process when you are dealing with that data. So this is one sample thing. Now how and one more thing I would like to share or discuss here is how can you simply access the zip file also. So now I'm taking one random zip file is there. Now this is the read CSV also trying to extract the zip file. Now I'm trying to use that one. Now again I have to mount this particular file so that I can load the drive. Now I'm running. I'm just trying to wait for the mounting process. Yes, I already mounted. Now my drive is loaded now. Now I'm going to my drive. Now I'm going to go to the FTP folder. In that my file is ratings.zip. So now I'm copying the path from here and I'm storing here. So now I'm trying to run by using the pandas. Yes, you can see here in this one I have the 4 different fields. So one is user ID, movie ID, rating, and timestamp data is there. But if you see this, you cannot directly see because it is zip value, zip file. So now I simply loaded that file and used the read CSV file from the data frame, and I could directly see the data frame which is actually extracted from that file. This is how easy it is to open the zip file also in the Python. So by using the pandas frame. Now I can also use the data file. Now I will try to use the dot data file. Copy path. Expected image. So I think I have not stripped properly probably that data file I have to upload and see. I'll show you later. Now how text data also you can simply see .txt file. Simply file dot read is a method which we can simply load this file and we can see that file. So this is sample code. Now likewise you can also load the environment files from the given path, but here I'm using the Google Drive. That's why I could not able to locate this file. But if when a local system is there, then you can simply load the environment information also. This is how we can load the different types of files in a Python by using the pandas or by using the JSON file, or maybe different types of file systems. So this is how and when we can apply the thing. Now you can observe that these entire data values, as I mentioned in the previous EDA. So this .csv file, suppose whatever the JSON file patio which I have seen now, I can simply load this file into here, so I can see it differently. Now patio dot underscore exe. So now if I run this one, probably okay. Now thing is I have to remount the things, so I will do that one because I already new file is created after mounting. Sorry for the interruption, some technical issue I got, so I'm just again presenting my. Now, one more important thing which we need to see in the Python library is how the metrics are going to be accessed and run. Now we have seen what are the different features available in a Python, and how the data is going to be stored by using the list, tuple, or other things, and how the machine learning libraries help us to perform the scientific computations. And also now we are going to see how to evaluate your metrics for the given thing. Now I'm just going to show you this metric slide, hands-on, by using this simple programs. So now I'm trying to load this particular one, and just to takes time to do that. And I run this. Now I mounted my thing, and I'm trying to take this same diabetics CSV. Now this all thing we have already seen. Now I'm just training this already I have made, but I want to load those values. That's why I'm again running this KNN for the accuracy purpose. Till now we have seen how the KNN is trained and predicted by using the Python libraries. Now I'd like to evaluate the metrics. Now I'm just taking the sklearn.metrics, sklearn.metrics, and I'm importing the accuracy score. Anyway, this I have already seen. Now the precision score, recall score, F1 score, and classification report, and all these things I could take from the thing. Either you can directly take the sklearn import metrics, or you can specifically call these functions to specifically call the whatever the required things. So now I'm just trying to run this one, and I'll show you how the confusion matrix you can get. So now suppose the confusion matrix is basically show you how many true positives are there, and how many false positives, and true negatives, and true positives. So all this classification report is going to be generated. Now I'd like to show you how actually the true labels were there, and the actual labels, predicted labels were this is the how the binary classification look like. Now in the diabetes we have seen that outcome is a 2, either 0 or 1. So the 0 means it is a negative value, and 1 is a positive value. Then it means a 2 classification. For that 2 by 2 matrix will get to know the confusion matrix. From that we can simply find out the precision recall. Now so this is again you want to show you in a different way of plotting. Then you can adjust that scale, range from the certain scale from 40 to 140. Now I'm trying to find out the other precision, or maybe with the help of the scores which we have got from the precision score, or maybe recall score, F1 score, and directly I can use those methods instead of thing. Now here accuracy score we already seen, that is how much percentage of classes I classified correctly. Now here the precision is here we are going to compute it with the help of a precision score function, and recall also using the recall score function. Now F1 score, like that we directly access those methods by using those particular one. Then you can simply see how much of those output values which, for the given classification. Now we want to know the complete report with accuracy and the micro average, weighted average. Then you simply print the classification report with the Y predicted and Y test. So I can run this one, and I could able to see the complete report of that particular one. So this is how actually the metrics packages will help you to seamlessly compute the error values or accuracy values, precisions, and so on. Suppose if I'm using the other regression part, I could use this different metrics like root mean square error or absolute mean square error or normalized root mean square error. Like that's different algorithms will use the different metrics. For that, you completely access those functions from the sklearn toolkit. So for this, I'll get back to the thing, the PPT which I have shared now. We can see the things, the prerequisitions of the ML, and we have seen the data sets, how we will load manually instead of taking the inbuilt data sets, and how you will use the sklearn functionalities to fit the training and prediction of those variables using the different algorithms. And also we have seen how the model selection will help you to divide your data into test and train data, and how you will cross validate, and how the metrics are going to be accessed to see the metric values of your algorithm. So these are all we have covered. So with this extent, I will say that I'll stop from here, and if any doubts, you can raise. Any questions from audience? Am I audible? Yeah. Thank you for giving me the opportunity to enlighten with this small information. Thank you.